Okay, the recording started.
The recording is started.
So, okay, so I'll start.
Feel free.
Okay. So hey guys, so today we'll be deep diving on an amazing session, which is on building autonomous knowledge agents. There's something very close to me because that is agents are something which have been the talk of the hour for the last year, and this year they are going to explode. There'll be a lot of workflows, a lot of automations that these uh, agents will take over, increasing efficiency, reducing cost. So today we'll be looking at a similar workflow where we'll be building a knowledge agent where we'll be using the MCP Toolbox, Agent Development Kit, Gemini as an LLM in the backend, and Neo4j as the graph database. Um, so before I start, let me give a brief introduction about me. So hello everyone. Um, I am Shubham Agnihotri. I have around 6.5 years of experience in AI and ML. I currently lead the AWS user group in Mumbai in India, and also was the organizer for ML Community Bangalore. I founded I love to work around with the community. I founded a startup um, of my own, and then when I'm not pretty much working, I'm pretty much delivering talks. So I was invited as a speaker at Chitex, Global Asia Tech Singapore, Textual London, and here Cloud8 Summit. Yes. And when I'm not pretty much coding, I'm pretty much lost in Himalayas. I love trekking. So if anybody wants to, if anyone is traveling in India and want to know some amazing trekking places, feel free to reach out to me. So firstly, I would like to thank Cloud8 Summit for inviting me for this amazing session. Today, we'll be covering GraphRAGs, which is yep. So today we'll be covering graphical rags, which was basically introduced by Microsoft and how it is much better than uh, traditional rags. So this is a QR code for the presentation if somebody wants to go through it or have a look at it at later. So this is the agenda that we'll be covering. So one is what are agents? Pretty much everyone is talking about agents. Uh, what are agents? How are agents currently different from the agentic workflow? How are agents different from the AI workflow that we have? What are agentic workflows? Then we'll be covering RAGs. What are RAGs? Then what is GraphRAG and how does Neo4j come in place when we talk about the GraphRAGs? Then we'll also be covering a protocol which is called a Model Context Protocol, MCP. What is MCP? Why do we need MCP? What is MCP Toolbox? And finally, we'll be covering the suite that brings all of it together, which is the LLM that we'll need in the backend and basically a toolkit that will help us create agents. So which is Agent Development Kit. And then I'll give you a hands-on walkthrough that pretty much you guys can try it on your own systems and develop an autonomous knowledge agent in the end. So what are agents? By the way, feel free to put questions onto the chat. I'll answer them in the end of the session. Yes. So in a very layman term, an AI agent is a computer software that pretty much takes or interacts with the environment, takes some information out, and uses that information to meet an objective. So there is a task given to it. Uh, for example, it can be, let's say, solve this query, extract me this information. How it does that is something that the LLM or the agent decides um, how to achieve that task. So uh, by the definition, it is like the humans set the goal, but the AI agent independently chooses what is the best action it needs to reach that task. So I work in a bank. So let's take an example of a customer call center. For example, I need to take a loan. I call the customer call center now. Um, in today's world, a person picks up the call and uh, answers my query. I ask him, okay, tell me about a home loan that I want to purchase. So now what the the agent or the customer care executive in the back end will look is it'll fetch some information about me in the bank database. It'll fetch the information about the home loan, and then it'll try to correlate saying that, okay, this person is eligible for this home loan, or this person is not eligible for this home loan, or these are the offers that are available. So this is what a normal human would do. Similarly, what an agent will do is exactly in the same order, where we say, okay, you need to answer this customer query, which is tell him about home loans. So what we'll do is we'll expose it to a certain set of uh, we'll expose our agent or our AI bot to an environment where it'll ping certain APIs, or it'll ping uh, certain databases to extract information out. The information over here, it can be about me, about the customer. The information here can be about the policies of the bank. And then once that collection of once the agent has collected the data, then what will happen is the agent will use that data to answer the query the customer has asked. So why do we need agents? So a lot of you guys watching present in this lecture or watching it online might have developed or might be working professionals, might know about AI workflows, agentic workflows. Uh, these are basic. First, let me cover what are AI workflows and how agentic workflows are much better than AI workflows, and the way the industry is moving towards agentic workflows. So, uh, AI workflows are basically a set of procedures that we define in the industry to perform and to execute a certain task. It is basically a structured pipeline with a clear, definite outcome, with a clear, defined steps to achieve that outcome. Whereas agentic workflows, it is more of an autonomous system where the agent decides what are the next steps it needs to take, and we give them the target, but how to achieve that target is something autonomous. Now, again, let's take of an example of an AI workflow versus an agentic workflow, where in an AI workflow, in a very layman's example, for example, I go to a restaurant, I say I want a dessert. I say, okay, make me a blueberry cheesecake. So if it was an AI workflow, so for making a blueberry cheesecake, I have the recipes, I have the ingredients, and these are the steps that it needs to be done. For example, take the batter, perform this steps, follow the recipe, and in the end, you have the blueberry cheesecake ready. So we have a structured pipeline. We have um, what we have is the way to achieve. So we have a defined goal, we have a defined pipeline, and we have the correct information to achieve it, and that's how we are able to that's how the whole flow gets executed. Whereas in agentic workflow, what I'll go is I'll go to the restaurant and I'll say something very similar. Say, okay, prepare me a dessert, or prepare me a blueberry cheesecake. So now what agent will do is, okay, it'll look at the ingredients. It'll say, okay, I may not have this, I may not have this, I have this. So based on that, based on the data it collects, it'll define a set of procedures, set of tasks that it needs to perform, or the steps that it needs to take in order to achieve the task. The task is I need a dessert. So what it'll do is, okay, based on the ingredients, it'll formulate a recipe and start executing on it. Or I need a blueberry cheesecake. It'll say, okay, this is the task that I need to perform. These are the ingredients. Now, how to achieve it based on the ingredients that I have is something that the agent decides. In the AI workflow, if I don't have a particular set of ingredient, the workflow might fail. In an agentic workflow, the agent will look for alternatives and it'll take decisions on its own and act. So what is the basic difference is one is in the decision making. Um, AI agents are dynamic, whereas AI workflows are predefined, executed in a deterministic manner. Agents are very flexible. Where we talk about customer query, customer can ask in the example of the customer query, the customer can ask any information. It can be home loan, it can be about an existing uh, credit card, or it can be about new offers that he has. It can be anything. The customer care executive needs to adapt, and AI agents are very well in doing that. AI workflows are more of rigid and better for repetitive tasks. Complexity is AI agents are difficult to build because they are prone to infinite loops, whereas AI workflows are simpler to build, and AI agents are more autonomous, whereas AI workflows are easy to control. So we talked about agents. Now um, we talk about knowledge agents. So basically, knowledge agents are agents where uh, AI or an LLM fetches an information from the database and gives you back a reply. For example, that technique is basically called RAG. So RAG stands for Retrieval-Augmented Generation. It is an AI framework that combines the basic traditional searches and combining it with an LLM. Uh, let's take an example of a Bing search, where what we do is I want to know about Cloud8 Summit. If it was just an LLM that was trained on the data, or let's say Cloud8 Summit 2026. So if it was just trained on the data, let's say till 2025, so the AI agent or the LLM will not be able to give me any information on that. Or let's say it was trained till 2024, it may not be able to give any information on that. So that is where RAG come in place, where what we do is we uh, we expose the LLM to certain databases where it we say, okay, you have been trained you have been trained on certain data, but uh, that data again can be will become obsolete over the period of time. So I need you to give me information which is very relevant to me. If I take an example for bank, the policies keeps on changing, the interest rate keeps on changing. I cannot update my LLM over and over again because that is expensive. That is where RAG comes in, where we say, okay, in a very, very layman's term, RAG is an AI architecture uh, where you take an LLM like a GPT and uh, give give it a certain knowledge, or give it expose it to a certain data, and it generates an answer. So if I talk about the agent definition that we talked about, it uses certain variables, it uses certain information, it collects data. That is where this data comes in. This is the knowledge that is being brought in. So RAG is basically we are using databases to extract or exposing the databases to an LLM and answering the questions that anybody asks. So now, what is the problem in this? Humans are very complex. The queries that we ask are even more complex. Where let's take an example of I'll take an example, and that example will pretty much run through till the whole presentation now. Where even in the demo, it's the same example. Now think of a company or an investment firm. Okay, now an investment firm has a database of all the companies, has a huge database of companies like their investors, the industry they are in, the type of work they do, has the information on the investments the companies had, the valuation of the company, the investor that they made the investment, and the time when the investment was made, and all these information. So think about, let's say, if I ask a query, okay, tell me who invested in OpenAI and who invested in Anthropic. So GPT was created by OpenAI and MCP was created, or Claude was created by Anthropic. So uh, in a traditional search, what will happen is the LLM, there'll be multiple queries running saying, okay, tell me about OpenAI. Who are all the investors in OpenAI? Then there'll be queries around, okay, about Anthropic, and then there'll be whole invested in Anthropic, and then there'll be an overlap. So this becomes very expensive and may lead to wrong results. Whereas graphical RAG, again developed by Microsoft, uh, gives an amazing solution where what it treats is it treats each data as nodes and the relationships and forms a relationship between the nodes. So over here we can have a node of company, we can have node of investor. And for example, let's say we say in OpenAI there are 10 investors. In Anthropic there are 10 investors. And then when we do a graphical retrieval, what we do is we say, okay, take the company, take one hop. So basically these are graphs. So you have two nodes and one edge connected to it. Okay, saying that, okay, OpenAI, these are 10 investors. Okay, Anthropic, these are 5 investors. And then these are the two overlaps happening. And that becomes very easier, very faster and more precise. So the same example, what will happen is we'll first chunk in a traditional RAG, we'll chunk the data. And once we chunk the data, uh, uh, we'll embed them into vectors and then there'll be a retrieval that is happening. Whereas in GraphRAG, we have the company which is present here. We have a company as a node, we have investor as a node, and the relationship is they have invested in it. So we can find all the common nodes to these two companies that we have. So it becomes very easy to trace, a lot more precise output, and uh, amazing in capturing context. So how do we achieve that? So for graph, we need a graphical database. That is where Neo4j comes in. So a Neo4j is a graphical database that, unlike any SQL or NoSQL database, it converts the whole data into entities and relationships and defines each relationship and entity with properties. So person, let's say a company, can have properties that is, okay, this is the company, this year it was formed, these are the founders, this is the amount it was raised, these are the functionalities or the description, these are the set of tasks that a company performs. Same goes with can be another entity which is investor. Okay, okay, this is these are all the companies here invested in. This is the investing pattern, or it can be anything about the investor. And then can be a relationship which is, let's say, invested in. So this at this time it was invested. This was the amount that was invested. So all of these you can store all these things, all these information and properties in both relationship as well as nodes. And with this, what happens is the reasoning becomes really strong. So uh, basically, I'm just doing a query search saying that tell me about who invested in YouTube. There's an example that we'll be doing in the code lab. So what happens over there is, okay, we say, okay, who invested in YouTube? There'll be a Cypher query for Neo4j for to execute a query. We use Cypher as a language. So what we'll do is, okay, it'll go in the backend. It'll find, okay, this is the company named YouTube and find its investors. So what it needs to do is it needs to only look at the relationship that is invested in the company, which is YouTube, and then invested in on all the relationships that it has will fetch it out. So the reasoning becomes really strong. Okay. So if I talk about um, now what we have is we have the agent. We know why do we need agent. We know, okay, these are the data where we'll collect the information from. Uh, so, but how do we link or these are the Neo4j is basically the place where we'll get uh, the data from which our agent will pretty much use to make a decision or to execute some steps. But how do this data is made accessible to the agent? That is where MCP comes in. So MCP basically stands for Model Context Protocol. It's an open source standard for connecting AI applications to external systems. So basically what you need is you need a client and you need a server in between, and that server gets connected onto various other applications or engines. Let's take an example of why do we need an MCP. Uh, a real world example. Right now, I'm trying to build a knowledge agent for my own system or for my bank. or it can be for for any XYZ agency. Right now I'm using Neo4j to fetch the data. But when it comes to production, my data may not just be on Neo4j, it can be on S3, it can be on Postgres, it can be on SQL. I might be running some flows on Slack after that. There'll be some pushes that'll be happening on GitHub post that. There'll be some alerts that'll be generated onto Grafana post that. So each of these have certain APIs exposed. Each of these tools have certain API exposed. So when I'm developing a solution, so for example, app one over here is my solution. I'm thinking about of an organization. App two is somebody else's solution. Somebody else is trying to do something similar in the same bank with trying to interact with different tools or similar tools that I have, but for a different use case. So what will happen is I'll develop a solution and it'll interact with these all the three tools separately. I'll be interacting with the APIs and I have to maintain these APIs separately for all of them. And then somebody else will do the same thing and they also need to do that. And similarly, there's another team in the bank performing certain kind of operation. They also need to do that. So this becomes an M cross N integration and which explodes when the number of tools increases, number of application increases. So what we do is we bring in an MCP server. All these applications connect to the MCP server in a very standardized protocol, and these MCP server then in turn connect to the tools. So if anything changes, the change requirement only happens at the MCP server end. So now my M cross N integration becomes M plus N, where M are the number of applications that I'm connecting and N are the number of tools that needs to be connected. So that is why we need MCP. So in our use case, MCP is a tool or MCP server is the one that we'll be using or we'll be hosting to connect it to Neo4j. The same server, we can expose it to any other data base as well. It may not only be database, it can be another application as well. For example, I say I want to um, I give an agent for scheduling my or for monitoring my calendar. And so I say, okay, I'm available from 2:30 to 3:30 IST for this session. Okay. So what it'll do is first it needs to retrieve that, okay, I'm available in this slot. And then if I am available, then it needs to book the meeting. So for it to perform those actions, it needs to have access to all these tools. So yeah, that is where MCP comes in. So now what we have is we have an agent. We know why we need an agent. We know why where what is the data that we'll be using. We know the example that we'll be talking about an investment firm and how we'll be connecting the data, which is how we'll be exposing the data uh, from the Neo4j database to the agent is from an MCP server. So this is how an architecture looks like. We have a client. We have a server and those servers are exposed to different data sources. It can be local databases, it can be remote services as well. And in the end, we use an MCP protocol to exchange information. Okay. So in this whole talk, we were talking about agents. Um, what all agents can do, why do we need agents, how agent will interact with the database, but how do we orchestrate the agent? How do we build an agent? How do we deploy the agent? That is where something beautiful comes in, which is our agent development kit. So agent development kit basically allows you to do four things, which is you can shape your agent to think, reason, and collaborate with guardrails in whatever way you want. It gives you the flexibility to do that. It helps you interact with humans. I'll be showing you the demo, a hands-on workshop where you'll be interacting with humans, where the UI will be exposed to you, and you'll be typing it down, and you can test whether the agent is working fine or not. It can be ADK supports both audio and video capabilities as well. So it pretty much covers all streaming services, all audio and video streaming services. You can choose your own model. You can choose your own tools. You can choose your own MCP servers. So it gives you the flexibility to do that. You don't want a GPT, you can use Llama. You don't want Gemini, you can use DeepSeek, whatever you like. And you can easily deploy with a click of a button. So this is how the whole architecture looks like, where um I mentioned something called as MCP Toolbox in the starting. So MCP Toolbox is basically an open source implementation of an MCP server that connects to various databases and services. So over here we can see different agents can connect to the toolbox. It can be a land graph, it can be the ADK, which is Agent Development Kit. The MCP Toolbox in turn gets connected to various databases. It can be MySQL, Postgres, um, it can be Neo4j, MongoDB, uh, Oracle, Redis, whatever. And similarly, if you want to interact, if you want the users to interact with the toolbox, that is where these development kits comes in. If you are running a software, or if you are doing coding, or if you are developing a solution, you can have these things as your IDEs. Over here, you can see VS Code coming in. You can have Cursor coming in. You can have uh, Windsurf and other uh, IDs and other things coming in to connect with these toolbox and provide you access to all these databases and information that you require, that the agent requires. So yeah, now without wasting some more time, let's go on to Code Lab. So basically, uh, talk is cheap. Code is something that everyone loves to see. Let's jump onto the Code Lab. So this is the Code Lab. I'll just zoom in a bit. Yeah. So mm, this is the URL. You can use this QR code to reach there. And yeah, so in this code lab, pretty much we'll be talking about Agent Development Kit, Neo4j database, and MCP Toolbox. Why do we need GraphRAGs? And kind of an implementation of how do we achieve um, an autonomous knowledge agent for, let's say, an investment firm. So over here, we have three agents, which is graphical database agent, investor research agent, investment research agent, and a root agent that orchestrates between all of them. So graph database agent pretty much queries Neo4j to extract the information. Investor research agent discovers investor relationships and investment portfolios. And investment research agent uses MCP to get information on the investments. So yeah, let's go on to so there are basically 8 modules. It is of around 65 minutes long. So over here, if anybody who really wants to understand what is GraphRAG, why do we need GraphRAGs? Traditionally different from how are they different from traditional rags? Is some you'll have a lot of theory around that. For example, if I say which movie the actors have acted in, which movie Tom Hanks has acted in, which movie Robert Downey Jr. has acted in. So if I have to build a SQL database, it'll be a huge table which will have a relationship of actors and movies. Whereas when it comes to graphical databases, it'll be a lot more smaller and a lot more economical for extracting that information out. Even when the queries get tough. For example, when we say what all are the Marvel movies that Robert Downey Jr. has acted in. Now there is one more aspect that came into being. So in a SQL database, it'll be another table and performing a lot of joins. Whereas over here, this is just one entity getting mapped to another entity. So yeah, so this is basically a very simple query that we talked about in the starting about who are the competitors of YouTube um, and which investors are funded in both YouTube and its competitors. So by just this query, we will be able to extract the whole information out. Um, Then we have the Agent Development Kit. Agent Development Kit is an open source framework for deploying production AI agents. I'll be showing you the code where we create agents, we give the sub agents, we give those sub agents certain set of tools by which it can execute certain operations. The MCP Toolbox, where again, it's an open standard for connecting AI agents to external sources and tools. I'll show you how we have created the toolbox. So let's come on to the next one. Oops, yeah. Okay. So over here, the data set that we have used is this data set. You can go on, you can click on this demo. It'll pretty much take you to this. It'll pretty much take you to Neo4j browser. Over here, you need to use the username and password as companies and companies. So this demo database will be available to you throughout. This will be available to you always. Over here, you can perform cipher queries to know more about the company. It's very simple. You just write the queries. You can say, okay, organization has competitors. So, okay, Hive has, these are all the different competitors Hive has. Let's say, let me increase the limit to 100. Let me zoom in a bit. Yeah. So let me increase it to 100 and let me execute the query. So it says, okay, now bow and arrow has, these are all the different competitors that this data has, these companies have. Gen Digital has these competitors. So this is just more towards an exploratory data analysis of the data that you have that you can perform on Neo4j. And then let's say we want to visualize uh, we need to find the investors and the portfolio companies. So let's go over here. Let's execute this. Where we say, okay, Sequoia Capital is the investor, and these are the portfolio companies that it has invested onto. Axel is an investor. These are the portfolio companies that it has invested onto. Insight Venture Partners are the investor. These are the companies that it has invested onto. So now we see, okay, it was such a fast and it was such a fast query where over here we just connected multiple databases. We connected the investor, which is organization, to the companies, again, which is an organization it invested onto, and linked both of them together. So what you need to do is you need to clone this repository. It is created by my friend. Just go on your terminal, clone the repository. I've already done it for you guys. Yeah. Okay. Once you clone the repository, you'll find something like this structure. Over here, you need to go on to example environment. In the example environment, so this is basically the structure looks like. You'll have agents. All your agents are written in agent.py file. I'll be going through it. You have the requirements, the txt, the code requirement that you need to run this code. Then you'll have an environment example file where you need to provide all the details. So the Neo4j information have already been provided to you, the previous modules. Over here also we have already provided it to you where you can use these demos. You can use this demo link and the companies as the username, password, and database. Then over here, because we are using Gemini, so that is where you need to provide the Google API key for Gemini. If you're using ChatGPT, you need to provide an OpenAI API key, and wherever the Google API key is being used, you can replace it with OpenAI. And then what you need to do is the model that you're pinging. Over here, we are using Gemini 3 Pro Flash, a Pro Preview. You can also use Gemini 3 Flash Preview or any other model that you wish to do that. And then we have the MCP toolbox. So this is a toolbox that we have created. I'll show you how we have created. So this toolbox pretty much connects with the Neo4j database. And once all of this information you have filled in, then pretty much what you need to do is, so this is just information about the example that we're trying to do. You need to run this command, which is uv run adk web. So I have already ran it for you. over here, which is, let me zoom in a bit. You see this command, which is uv run ADK web. As soon as I do that, I'll have a server running at a local host. I can, once it is hosted, once we deploy it, it will be running on a URL. So this is how the whole user inputs. This is what the a session of an ADK looks like. Now that this becomes very interesting and very easy for us to build agents now. I'll tell you why. So for example, if I come to the come to my this thing, I'm saying, okay, what all industries are available in the database. So I come here, I go here, I type this, what all industries. Let me start a new terminal and let me do it with you guys. So I'm running, I go to this environment. I've already installed all the libraries. I load that virtual environment and I'm running it on the server. So I'll just refresh this session and I say, okay, what all industries are available in the databases? And I enter it. So what will happen in the backend is uh, this query will first get embedded and then it'll go to the root agent. The root agent will decide which agent it needs to ping in order to extract that information out. Once it decided, then it'll ping that agent. That agent will perform its own task. It may be, looking into an existing database, connecting to an MCP server, and extracting that information out, and then giving that information back to the user. In the meantime, while it is being connected, so that is the beautiful part about ADK, where you can also always see, okay, you have the root agent, then you have these three agents, which is the investor research agent, the investment research agent, and the graph database agent. So in the ADK, uh, you can always perform, you can always have a look at oh, what were the input tokens, what were the output tokens that came into being, what were the actions that it needs to take for you to easily understand and go through. So for example, okay, it went on to the investment research agent. It says, okay, I need to find, okay, what industries are available in the database. Okay, it says, okay, I need to look at the about the investments that I have. So it is not about the investor. So it is about the companies that have been made investments onto. So that is where, okay, it um, decides to, okay, go to the investment research agent. Then what it does is it pings the graphical database, because in the end it needs to extract that information out from the graph. So it pings the graphical database. Over here you can always have a look at, okay, uh, the tokens it is being consumed, um, the signature that it has, it is using the get schema function. And then okay, it says, okay, it is extracting some schema out, and then it is performing an executable, then it is performing a read query. Read query is, okay, these are the results that we have from okay, this is basically the schema that we have. Let me take you with this example. Yeah. So okay, so over here I performed the same query, and what it did was it went to first getting the schema out. So if you look over here, you can see, okay, it got the schema. It got the schema. Then what it did was it performed an execute query. In that execute query, it performed certain information. It tried to extract all those information of the companies that we have. Then, okay, it says, okay, these are the list of companies that I have. Okay, enterprise software, computer, hardware companies, and various other industries. Now, because it's a big query, it is performing this over multiple period of time, and then it is summarizing it. Okay, saying that, okay, there are around 258 unique industries that we have. Uh, from A to Z. On A, we have accounting, advertising. From we have youth organizations, we have vehicle part manufacturers, and whatnot. So what in the end it did was we just asked a query to the to our agent, and that agent in the end what it did was, okay, it itself figured out, okay, I need to ping to I have three these subordinate agents. I need to ping to this agent in order to answer this question. And then this agent was pretty much connected to an MCP server where it asks this query key, okay, fetch me the information about the industry that these companies are in. And then um, once the once the answer was ready, the agent pretty much formulated a structured reply, not for structured reply for us to for the end user to read it. Now, let's say I asked another question, which was who invested in ByteDance? We did the same thing where, okay, it says who invested in ByteDance, so it goes to the investor research agent. If you see over here, it goes to the investor research agent and it tries to get investors out. Now it is trying to fetch the investor functionality. I'll show all these functionalities to you in just some time. And what it does is, okay, if we then it says, okay, these are the investors, and then it is trying to fetch some information about the companies. So you can also always have a look at what exactly is going into their model. You can expand all these things and see these are different states. You can see request, what was the exact request that went on to, what was the exact response that came after I sent the request. So for you to see, okay, this is what is going to the LLM at that particular point of time. It becomes very easy to trace errors. Why you are getting this error, why you're getting that value, or why it is not being able to fetch that. And you can also figure out at what place is your agent breaking, because agents are slightly complex to build. They are highly autonomous, so it also becomes very easy for them to wander around and not give a correct output. And that is where what you do is you start putting in guardrails instead of more instructions, and this process becomes very easy to debug. So once we were able to do it, okay, it says, okay, this is the query that I need to run on my database to extract this information out. Then it runs this query, and it says, okay, this is also the query that I need to run on the database. It runs the query, extracts the information, and then based on the data, what it does is, okay, these are the people, individual people, and these are the organizations that have invested in ByteDance. That's how. So these are all the different queries that you can execute. You can see what is the expected behavior, what to expect for each of them. And once that is done, so there are around 8, 10 queries that we are executing. Once that is done, what you can do is you need to do the cleanup, where you need to clean all the resources that you have and then shut down the code lab. So let me give you a small walkthrough. We are just running short on time. So I'll just give you a small code walkthrough on this, which is majorly all the code is written in the agent.py file. Okay. Yeah. Okay. So over here there is a root agent. Um, the root agent is called the investment agent that we saw over here. The investment agent. That agent is exposed to investor research agent, investment research agent, and graph base agent. Now we go on to the investor research agent. Okay, the investor research agent, we define an agent over here. We say, okay, how do we define an agent over here? We have an ADK support of agents. We do an ADK import and we get an agents over here. And over here, then we define our model that, okay, what is the model that we want to use? It can be Gemini, it can be GPT, it can be whatnot. And then the name of the agent, the task it needs to perform, the instructions, and the tools it has been exposed to. Similarly, we'll do the same for uh, the graph database agent. The instruction, the name, the instruction, these are the instruction basically the agent needs to perform. So this is about performing, executing cipher queries, writing cipher queries. So there are tools over here. It is get schema and execute query. So if we click on get schema function, get schema function, what it does is it just executes the query, whatever we have. And so you get schema, extract the schema, and execute query is basically the function where whatever query we ask, we just uh, the agent tries to execute that on a Neo4j database. Yep. So basically, we are getting a query as a string. We are using driver.execute query. We are doing a Neo4j connection, and that's how it is being able to execute the query. So if I talk about the let's say the tools that we have. So if I see where my tools are being defined, tools equals to tools. We have for the graphical agent, we have the schema and execute read query. For uh, investor research agent, we have the schema and get investor tool functionality. And then um, for the investment research agent, we have the MCP Toolbox URL, the URL that we talked about. So over here, if I give you an example of the URL, so this is how you set up an MCP, how you set up um, the MCP toolbox for interacting with the Neo4j. So this setup script is to generate the tools.yaml from the environment variables, the environment variable that I showed you. And over here we have defined, okay, this is how my graph looks like. These are the tools that I have, which can be, extract company's information. Uh, it can be, let's say, the company's ID name, the summary of the industry that they are in. It can be about the industry names. It can be the articles. It can be on uh, the company graph. The article is basically some article mentioned on the company. It can be the company graph, the organization, the hierarchy, board members, and all those things. So all these queries, and over here we have also defined, okay, this is the query that needs to be run. These are the parameters that takes in. So whenever we say, okay, get me an information about who is the board member. So it says I need to get the company ID, which ID you're talking about. That's it. We have only one parameter, that the company ID, and then it'll pretty much run this kind of a query. That is where we define in an MCP server. Okay, these are the set of queries that you need, that the current um database we can perform onto. So that pretty much brings me to the end of the today's session. I'll just go back to the slide, and yeah, so this is my LinkedIn. Feel free to reach out to me, ask me questions, and if you have any questions, please put it onto the chat. And yeah, I'll just stop sharing my screen.